let's go ahead and graph quadratic functions. So we're still in quadratics, but we're going to graph them in a different form. So we're going to be covering vertex form. So up until this point, we've only talked about quadratics in standard form. So you're going to be seeing quadratics in vertex form, which look a little different here. So in the form, we can identify three values, which are going to be A, H, and K. So let's look at this example here, and let's match your K, which is 3 in this case, your H, which is 2, and your A, which is going to be -2 as well. So let's go ahead and label each of these values, and we're going to be using it to answer different parts of our parabola that we're going to be graphing at the end. So let's go ahead and label all those values there. The 3 should be K, and we're going to go ahead and fix that right now. So part A is telling us to find a vertex. Lucky for us, when it's in vertex form, we don't have to do any work, any calculations to find the vertex. It's already given to us in the equation. So let's match our K here and our H. So the H is going to be your X coordinate, which is going to be the opposite of how you see it in your equation because of the form that your vertex is given in. The K is going to be the same value as you see it in the equation here. So let's go ahead and identify the vertex here. It's already highlighted, so if you see that the blue values highlighted in blue, we know that that's our H. So remember, and this is where most of the mistakes are going to happen. We're going to forget to take the opposite of the H. So since our H is +2 here in our problem, our vertex is going to have a -2 for our X coordinate. Our K, like I said, is going to be the same. So since we have it as +3, our Y coordinate of the vertex is going to be +3. So there it is. Just like I told you, we don't have to do any calculations. We just identify those values from our problem already. Let's look at our A, which is what our part B is asking us. Does this parabola open up or does it open down? So we know that our A is -2 here. So that means that the parabola is going to be opening down. What does that mean? Our parabola is going to have a max for the vertex. It's going to be the maximum value of our parabola here. So just again, let's explain why. It's because your A is negative. Second part, or part C, is asking us to find the y-intercept. And this is where we're going to need to do calculations versus when it was in standard form, it was always the C. But because our problem is not in standard form, we don't have a C. Therefore, we need to do some calculations to find the y-intercept. So for the y-intercept, your point is always 0, comma, whatever we get for the y-coordinate. So since our X coordinate is always 0, we're going to plug in 0 everywhere we see X in the equation so that we can find the value for the Y coordinate. So I'm just going to recopy our problem. The only thing I'm going to change is where I had our X, which is inside the parentheses, I'm going to replace it with 0. Everything else, I'm going to keep it the same. So the only thing we're doing is changing that X value. So let's go ahead and just rewrite it here. And then I'm going to follow PEMDAS. So PEMDAS says to do parentheses first, which is the inside of the parentheses. So I'm going to do the 0 plus the 2. And then everything else, I'm just going to rewrite it. So inside the parentheses, we get 2, since 0 plus 2 is 2. Everything else, I'm just going to bring down. PEMDAS says to do exponents next. So I'm going to go ahead and do 2 to the second power, which means I'm multiplying 2 twice. So 2 times 2 is going to be 4. So we get 4 for our exponent. Everything else, we're just going to bring it down. And since we have like the 2 and then the -2 and then parentheses, that means multiplying. So that's why I have that little dot there. After exponents, we're going to multiply. And we get -8. Bring down the +3. And lastly, we have -8 plus 3, which ends up giving us -5. Since the -a and the 3 have different signs, we subtract them instead of adding them. So we found our y coordinate for the y-intercept. So the point that we're going to graph for the y-intercept is going to be 0, -5. So just remember your x-coordinate is always 0. So to find the y-intercept, we're always going to plug in 0 to the function or to the equation. So we have 2 points in our parabola. We're going to go ahead and plot those 2 points. We're going to use the axis of symmetry to help us get a third point. So let's go ahead and set up this graph on this blank grid that we have here. So I'm going to go ahead and draw my y-axis, which is that vertical line. And I'm going to draw my x-axis, which is that horizontal line. Since we don't have a lot of positive y values, I'm going to place my x-axis towards the top, not in the middle because we do need some positive y coordinates, but mostly we need negative y coordinates. So just to spread out my graph, I'm going to go ahead and scale my y-axis by skipping 2 little boxes for every coordinate that I have, for every value of y. So I'm going to do the same thing for the negative y values, skipping 2 boxes all the way until we finish. So I'm just going to, until we finish on the grid, so I'm just going to make it until -7, although we mainly just need to go to -5 since that's the only y value that we have for the negative, which is our y-intercept. On my x-axis, I'm going to skip 3 boxes just so we can spread out our graph. And that's what I recommend you guys to do. Try to spread out your graph as much as you can. That way our parabolas on the whole grid that we have versus like a little tiny space if we didn't skip any of those boxes. Okay, let's go ahead and plot that vertex, which was at -2 and +3. Let's go ahead and place that in that pink or red point there. Let's go ahead and place our y-intercept now, which is at 0, -5. You see that green point. And we're going to draw our axis of symmetry in orange. It's that vertical line that goes through the vertex, which means it splits the vertex, it splits the parabola into 2 symmetrical parts. And you're going to see the reason why we're going to use that to get that third point. Because right now we only have the right side of the graph, the right side of the parabola. We only have a point to the right of the vertex. We need a point to the left of the vertex so that we can get that U shape. So I'm counting how far the y-intercept is from the axis of symmetry. So it looks like it's 6 units here. So since we know that it cuts it in half, I'm going to be reflecting that green point to the other side to get the other point on the left side of the axis of symmetry. So I'm going to count 6 boxes again. And that's where we're going to have our third point. There we go. So we have our third point in our parabola. That's enough so that we're able to draw that U-shape graph. And that's what I want you guys to do all the time. To get that third point, just go ahead and count how many spaces your y-intercept is from the middle of the graph. You guys don't have to always draw the axis of symmetry, just count the boxes, but it's easier to visualize it if you have the axis of symmetry there. So there we have our quadratic and vertex form. And I hope this video helped you guys.